Welcome to another concept in chemistry. In these notes we're going to talk about solutions and molarity. We're going to start these notes off with a definition of what a solution is. Okay, so a solution, we've actually worked with solutions before, all this year in labs and stuff, is basically just a uniform, homogeneous mixture of two or more different substances. That means that these two substances are mixed so well together that we cannot tell the parts, from each other. So it's like these in this example right here. These are what we call solutions. We can see that they're made up of liquid parts, but we cannot tell, the different layers or the different substances that actually make them up because they are homogeneous. All right, so when we have a solution, we have two different components to this solution. The first is what we call a solvent, and that is the substance found in greatest concentration or quantity, and this one is going to do the dissolving. Okay, it does the dissolving. On the other hand, we have what's called a solute. A solute is the part of the solution that's found in least concentration, and it's the one that gets dissolved. So if we have a solution of salt water, sodium chloride, that's been dissolved in water, the solvent is the water because the water is the one that does the dissolving, and it's usually going to be the one that's in greater concentration. Now the salt is what we call the solute because that's the thing that gets dissolved in to make the solution. So if it's getting dissolved, it's called the solute, and the solute's always found in lower concentration than the solvent. All right, and the last little definitions that I want to go over on this slide is just the term soluble. If you read something that says, blah, blah, blah is soluble, basically it just means that it's able to dissolve. Okay, so soluble means it is able to dissolve. So when we're talking about solutions in chemistry, we need to talk about this concept of molarity. And it's not a new concept. It might just be a new name for you because molarity basically is just a chemistry word that means concentration. Okay, so the concentration of a solution. So if you remember back when you were kids, perhaps your mom made you some Kool-Aid or you made yourself some Kool-Aid and you had to scoop 2 or 3 tablespoons of Kool-Aid powder into your 8-ounce cup. Okay, so what you were doing was you were making a solution of a specific concentration or molarity. The more teaspoons that you put of Kool-Aid that you put into the cup, the more concentrated it was. The less teaspoons you put of Kool-Aid into the cup, the less concentrated. Okay, so we can say that, more teaspoons equals more molarity or higher molarity, and less teaspoons of Kool-Aid equals, less molarity. So, again, not a new concept, just a new name. All right, so molarity, when we're working with it in practice problems and in the lab, making solutions, the unit for molarity is capital M, and you've probably seen that before in some of the solutions that we've used in lab labeled in the classroom. So we've got, 6.0 capital M, 2.5 capital M. That's all just stands for the concentration of the solutions. So when we need to figure out the the molarity of the solutions that we're making, this is the formula that we're going to use. Okay, molarity is equal to the moles of your solute. That means, remember, the stuff that's being dissolved, like the Kool-Aid. So moles of solute divided by liters of solution. And liters is super important. You always have to use liters every single time. So if you're given something in milliliters, or if you have to, if you're measuring out in milliliters in your lab, you need to convert that to liters when you're doing your practice problems. Okay, so moles divided by liters. And for those of you who grew up with the density triangle, right there in the middle is the molarity triangle that you can use. Okay, so moles on top, molarity on the left, and liters on the right. Okay, so this last thing right here is just, kind of an example. Say we have 2.5 molarity sodium chloride solution. What that means is that you have 2.5 moles of NaCl in 1 liter of solution. Okay, so that's what 2.5 molarity means. You have 2.5 moles of NaCl in 1 liter of the solution. Okay, so let's practice using this molarity formula to solve for problems. Let's start with some practice problems that ask you to solve for molarity itself. So here are two kind of examples that you may have. In the problem, you may either be given moles of the substance, which is great because then you can just use the molarity formula, moles divided by liters. But if instead of moles of a substance, you're actually given grams of that substance, then you have to take that extra step. And the extra step is to convert grams to moles, right? And you know how to do that. We've done those conversions. It's just, one bridge, mole island conversions, going from grams to moles of that substance. And then you can use the formula moles divided by liters, because if you look, it's not grams divided by liters, it's moles divided by liters. So anytime you see grams anywhere in the problem, you always have to think, okay, gotta convert that to moles first. Okay, and then also remember that one important thing, that the volume always has to be in liters. So if we're given milliliters, we have to convert that to liters. Basically, if you're given milliliters, just divide by 1,000. Move that decimal over 3 times to the left, and you've got yourself liters. So let's take a look at an example. So we've got here, what is the molarity of a solution with 35 grams of potassium chloride in 350 milliliters? So we've got grams of potassium chloride, and we have our volume here, 350 milliliters. So we have what we need in order to find molarity. We just have to figure out the steps. So here we're given 35 grams. So if we're given grams, we need to convert those grams to moles first. So let's do that. So 35.0 grams of KCl over 2 moles of KCl. Okay, so remember 1 mole is however many grams it says on the periodic table. So let's take a look at that. Well, potassium is 39, chlorine is 35, so you add those two together and you get 74 grams in 1 mole. So if we do that calculation, 35 divided by 74, we actually have 0.473 moles of KCl. Okay, so we're going to use that in order to solve for molarity. So we're going to have molarity is moles that we just figured out, so 0.473 divided by the liters of solution that we have. Now, in this case, we have 350 milliliters. So to convert it to liters, we just take that decimal and move it over 3 times to the left. So we've got 0.350 liters. So if we do that math, we're going to end up with 1.35 molarity. Okay, 1.35 big M. All right, so that is the molarity of a solution if you put 35 grams of potassium chloride in 350 milliliters of water. You'll end up with 1.35 molarity solution. The next type of problem is one that might be asking you to solve for moles of a substance. And so remember in our molarity triangle, if we're going to look for moles, we cover up moles and we end up with molarity times liters. So that's exactly what we're going to use, molarity times liters. So if we take a look at this problem down here, it says how many moles of lithium chloride are in a 250 milliliter solution of 3.0 molarity. Okay, so we have our liters here, okay, or at least our volume that we can convert to liters, and we have the molarity that we're given. So in this case, it's going to be relatively simple. Moles is molarity times liters. So we're going to do 3.0 times, and then remember we need to always convert the milliliters to liters. So we'll divide it by 1,000. We'll move that decimal over 3 times to the left. So we're going to have times 0.250 liters. So when we do that calculation, we're going to end up with 0.75 moles of lithium chloride. Okay, so if you have a solution, 250 milliliters of a lithium chloride solution that is 3.0 molarity, inside of that solution you're going to have 0.75 moles of lithium chloride. Okay, so those ones are the relatively easier ones. Okay, let's take a look at the next type of problem. Next, we're going to take a look at solving for liters or volume in a problem. Okay, so again, super simple if you're given the number of moles of your substance in the question, because then you would just do, liters is moles divided by molarity. But however, remember, if you're given grams, anytime you're given grams don't help us at all. Just like stoichiometry, in molarity, grams don't help us. So we always have to convert grams to moles first. And then we can use our liters equals moles divided by molarity. All right, so let's see how this works. In this example problem, it says, how many liters of solution do you have if you dissolved 15.4 grams of NaCl to make a 5 molarity concentrated solution? So let's take a look. All right, so in this one, remember we're given grams of NaCl. So if we're given grams, the first step is to convert it to moles. So we're going to take 15.4 grams of NaCl, and we're just going to do one bridge to moles of NaCl. And remember, we're going to look on the periodic table to get grams in 1 mole. So 1 goes on top, and if we take a look, sodium is 23, chlorine is 35, so if we add them together, that's 58 grams in 1 mole. So if we do that calculation, 15.4 divided by 58, we're going to end up with 0.266 moles of NaCl. So that's what we're going to use in our to solve for liters in this problem. So let's take a look. If we solve for liters, liters is moles divided by molarity, excuse me. I should say molarity. So we're going to have 0.266 divided by 5. So we're going to get, in the end, 0.053 liters, okay, 0.053 liters is our answer. Okay, you can convert that to milliliters by moving the decimal over 3 times to the right if you understand that. So that would be 53 milliliters. But that's that's how you do that. That's how you solve for liters. All right, let's take a look at the very last type of problem that we're going to see tomorrow in class, and it's solving for the grams of a substance. All right, so here's our last example for these notes, and this one has to do with how do I solve, if I'm asked to find grams of something, how do I do that with molarity? So there's 2 steps to this, because remember, grams are, difficult. They're the problem child here. So first thing you have to do is you have to solve for the number of moles first. So you can use, you'll be given molarity in liters, so you can multiply those 2 together to find the number of moles. Now once you have moles, you can easily use your periodic table to convert it to grams. So let's see how this works. Here's an example problem. It says, how many grams of sucrose are in 1 liter of soda with a molarity of 0.75 molarity? So let's take a look and solve this. So we're going to first solve for moles by doing molarity times liters. So we'll do 0.75 times 1.0. Well, look at that. It's 0.75 moles, right? So then we use our molarity or mole island bridges, and we're going to go from 0.75 moles, right, of sucrose over to grams of sucrose. Okay, so C12H22O11, that's a huge one. Okay, so remember 1 mole, and then we have to add 12 carbons, 22 hydrogens, and 11 oxygens all together. And so when we do that, it ends up as 342 grams. So if we do 0.75 times 342, we're going to end up with 260 grams of sucrose, which is sugar, okay, table sugar, in 1 liter of soda that has a 0.75 molarity concentration, which actually most soda is around there. So if you drink a liter of soda, you've just consumed 260 grams of sugar. Congratulations. All right, and congratulations, we made it to the end of these notes, and we'll see you tomorrow for lots of practice problems and a lab involving molarity.